Hello students, welcome back. Let us continue with chapter 13, surface areas and volumes. We'll start with a new topic, surface area of cuboid and cube. So have you ever seen a piece of paper? Of course you have. If you see, it has two dimensions because it's two-dimensional. So which are the two dimensions? We have the length and we have the breadth. So if I pile these papers on a stack, so one paper on top of the other, I'm left with the breadth, the length and this height, right? Because the height of the stack is going to keep increasing. Therefore, this entire region, let me mark it with a yellow chalk, it becomes the height, right? And finally, if you glue all these papers together, then you will have something similar to this. So this is an example of a cuboid. So my duster out here is an example of a cuboid. It has 6 faces. So now if you actually want to construct a cuboid, how do you start? You will take the base, which is going to be a paper or a piece of cardboard. Again, it's going to have two dimensions, which is length and breadth. So let's mark the length. This is going to be the length, this is going to be the breadth. Then you're going to add 2 walls to it. So if this is your duster, you have initially taken, for the first figure, you're just taking the base. Then you're taking the 2 walls out here. So you're left with the breadth, the length, and this is the height, right? So the 2 walls at the sides are added. How about these 2 walls over here? So I have added the walls here, one here and one behind. So this is the third one. And without the lid, when you open this paper altogether, this is what it will look like. The paper will look something like this. So how? This is going to be your paper which was there at the base. This was the long walls, right? Long walls here, and these are the short walls. So, and if you add a lid, then the lid will measure exactly as this. So this is equal to this. And this is how the entire opened cube will look like. So the total surface area is going to be the sum of 6 sides. So which are the 6 sides? The 6 sides are 1, 2, 3, 4, 5 and 6. So just like I showed you here, it has 6 faces. 2 of the faces are going to be congruent. 2 of each face are going to be congruent. So this face is going to be congruent to this to this and this to this. So what did we learn for a cuboid? That it has 3 dimensions. 3 dimensions, which is length, breadth and height. So let's mark the length, breadth and height over here. So this was the base. Here I have the breadth. This is also the breadth, right? This region is the height. This region is also, sorry, this is the length because it is the base. So this is the length and this is also the length. And we have this as the height, right? So this region is the height. So area of this is going to be area of this. So let's find the total surface area. So instead of total surface area or surface area, I'm just writing here. For the base and the lid, it's going to be twice length into breadth, right? Plus we have the long walls. So this was the height, right? So this is also the height and this is the length. So for the long walls, so again I have this as the, okay, so let's take into consideration this 4 and 5 are congruent to each other. So what is the area going to be? Twice length into height. Why? Because length into height for this and length into height for this. So this is going to be twice length into height. And finally, see, this is the height and this is also the height, right? See, this is the height, this is also the height. When you open it up, it's going to look something like this, right? So each of these are equal. So you have the breadth here and you have the height here. This is also the height, because they are going to be attached to each other. When they see, when you open up, they are looking something like this, but when they attach, they are of the same height. So here, so area of 1 and 3 are equal to each other. They are congruent as well. So area of these 2 faces would be twice breadth into height. So the total surface area is going to be, if I take 2 common outside, I am left with what? Length into breadth plus length into height plus breadth into height. So this is the total surface area of a rectangular cuboid. It's going to be twice length into breadth into length into height into breadth into height. So this was about a rectangular cuboid. How about a cube? You know that a cube, all the sides are equal to each other because they are made up of square shaped figures, right? Or square shaped areas. So each of these length, breadth and height, they all are going to be equal to, let's say, some length A. So each of these will be replaced. So this was total surface area of cuboid. How about cube? All L, B and H are going to get replaced by A. So it is going to be 2A into A plus A into A plus A into A. Right? So this is going to be how many? See, you have A into A is A square, then A square and A square. So this is going to be 2 into 3A squares, right? Because A square plus A square is nothing but apple plus apple plus apple, which is 3 apples. So 3A square. So this is going to be 6A square. So in general, the total surface area of your cuboid, so I am going to erase this section and write it neatly for you. I hope you have taken a note of this. So I have total surface area also known as surface area or also known as TSA. So for a cuboid is nothing but a rectangular cube, right? So this is going to be 2 length into breadth plus breadth into height plus length into height. So here L appears with B and H, then B appears with L and H appears with L and B both. So this is how you can remember. Then how about cube? For cube it's going to be 6S square, or instead of A I'm just saying S. Why? Because S we can just say it's the side or any edge of your cube. So if you're given any side or edge of the cube, then it would be 6S square. That is 6 into the side square. Now, so we spoke about the total surface area, which includes, see again coming back to this duster, the best example that we have for today. We have the base as well as the roof. Let's say this was the house and you need to only paint the walls. So obviously the ceiling and the ground will not count. You will have only the walls, right? So how many walls are there? We have 4 walls. So the 4 walls are also known as, calculating the area of 4 walls. Of 4 walls is also known as finding the lateral surface area. So the lateral surface area would be that of the 4 walls. So here you have the length, right? You have the height, then you have the breadth and you have the height. You do not have the length and breadth together because the length and breadth are only for the base and the roof. So the lateral surface area or curved surface area or lateral surface area, so I am just saying LSA, is going to be twice into these two sides, right? So twice length into height plus twice breadth into height. Why length and breadth are not being taken into consideration? Once again, because they form the length and breadth form the base. So if I take out 2 common, what am I left with? 2 LH plus BH. So finding the area of your the lateral surface area, the length and breadth together won't count. Length will come with height and breadth will come with height. And the curved surface area or the lateral surface area of the 4 walls is 2 LH plus BH. So please note 2 is outside, you have LH plus BH inside. Similarly, you have 2 outside over here. Many a time students they get confused with 2 LB as one single entity plus BH plus LH, which is wrong. The 2 is always outside, then you have the rule of BODMAS. So this entire term comes together within the bracket. Similarly over here. So this was about a about finding the lateral surface area of a rectangular cuboid. What about a cube? If you need to find the lateral surface area of a cube, again, if you notice, this is going to be A. So this is for lateral surface area of cube. Right, this L and H will be nothing but A or S. Let's say side. So S into S plus S into S. So this is going to be S square plus S square. So S square plus S square is 2S square. So 2 into 2S square, which is going to be 4S square. So what did we learn today? We learned about the total surface area of cuboid and cube, and the lateral surface area, which is 2LH plus BH and 4S square. So revising once again, total surface area of your cuboid is 2 into LB plus BH plus LH, where L, B and H stand for length, breadth and height of the cuboid respectively, and for the cube it is 6S square. Now the lateral surface area of the cuboid is going to be 2LH plus BH, and lateral surface area of the cube is going to be 4S square. So how do you relate these? For example, if you take the cuboid, the total surface area of the cuboid and the lateral surface area of the cuboid, see, you have 2 outside for both. Inside, one term is missing over here in your lateral surface area, which is that is going to be the base, that is L into B, right? So there is a relationship between the total surface area and the lateral surface area of your cuboid. Now for the total surface area of your cube, you know that for the cube all the edges are equal to each other. And how many edges are there? 6. 6 into side square. Similarly, 2 sides are going to be missing in your lateral surface area of the cube. So you're going to just deduct 2 from this. You will be left with 4S square. Simple. Please take a look. So we'll take a look at the solved example based on these topics in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.